In this video, I'm going to show you the types of constraints and how you can use them in Inventor. The first constraint I want to show you is coincident. You can use it on points, lines, circles, arcs, and splines. For example, there's a line and a circle. When I apply the coincident constraint on the center point of the circle and on the line, this will bring them together. However, the center point of the circle will not just stay inside the line. It can move along the line and outside the line like this, but it can only move in the direction of the line. This is one way to use the coincident constraint. The second way to use the constraint is to bring 2 points together. For example, if I click here at the end point of this line, and then the center point of the circle, this will bring these 2 points together. The second constraint I want to show you is collinear. You can use it on lines, and for example, there's a line here and this line here. When I want to make them in the same level, I can apply the collinear constraint. Let's say in here and here, it will bring these two lines into the same level. It happens a lot when you have a continuous line. And now when you trim the line into two pieces, let's say in this line, this is continuous line, and you can trim it. This portion is gone. It might look like they are in the same level, but Inventor is no longer the same level. You will have to apply the collinear constraint on these two lines to make sure they are in the same level. The next constraint is concentric. You can use it on circles and arcs. Basically, it will bring the center point of the circles or arcs together, just like this. And the next one is equal. You can use it on lines, circle, and arcs. When it is lines, let's say this example, when you apply the equal constraint, it will make these two lines have the same length. And when you apply it on arcs or circle, you will make the arcs or the circles to have the same radius. The next constraint is parallel. You can apply the parallel constraint on two lines, and these two lines will become to parallel to each other. And then the perpendicular constraint, very similar. You can apply it into two lines, and you can make these two lines perpendicular to each other. For the horizontal constraint, you can apply it on the line and make this line horizontal. And you can also apply it on 2 points. For example, you can use this point, the midpoint of this line, and also the center point of the circle. Once you apply the horizontal constraint, these 2 points will be aligned horizontally. Similarly, when you have a vertical constraint, you can apply it on the line. It will make the line vertical. And you can also apply it into 2 points. For example, you can apply it on this point, the center point of the circle, and the corner of this rectangle. And then once you applied it, these 2 points will be vertically aligned. And there's a tangent constraint. You can use it on lines, circle, and arcs. Let's say here there's a line and a circle. Once I apply the tangent constraint, the line will be tangent to the circle. There's a smooth constraint. You can use it on line and spline. Let's say in here there's a spline and a line, but this joint is not smooth, so you can smooth it out using this constraint. Fixed, you can fix all these items so that they cannot move, and you cannot dimension it, you cannot put a constraint to it. Symmetric, you can use it on line, circles, and arcs. For example, you want to make these two circles are symmetric to each other, you can apply that. Basically, these three constraints are not used very much in this class, particularly the fix, we don't use it at all. So what you have to do is to use these constraints, the horizontal, vertical, tangent, and also the coincident, collinear, concentric, equal, parallel, and perpendicular. These constraints are used regularly in this class.